Ever looked up at an apple falling from a tree and thought, gravity? Or maybe you've marveled at a telescope bringing distant stars into focus. Or perhaps you've even pondered the seemingly simple act of light streaming through a prism, creating a rainbow of colors? These everyday phenomena, and countless others, are deeply intertwined with the work of one of history's most influential minds, Isaac Newton. But beyond the falling apple and the laws of motion, what exactly is Newton known for? What were his groundbreaking contributions that continue to shape our understanding of the universe centuries later? That's precisely what we're going to explore in this video. Forget the dusty textbooks and simplified explanations. We're diving deep into the multifaceted genius of Isaac Newton, uncovering the scope and significance of his discoveries, and understanding why his name remains synonymous with scientific revolution. Before we delve into his specific achievements, let's paint a picture of the world Newton was born into. The 17th century was a period of immense intellectual ferment. The Renaissance had sparked a renewed interest in classical learning, and thinkers like Copernicus and Galileo had begun to challenge long-held Aristotelian views of the cosmos. The idea that the Earth was the center of the universe was slowly giving way to a heliocentric model, but many questions remained unanswered. How did the planets move? What force governed their celestial dance? What was the nature of light? These were the burning questions of the day, and into this intellectual landscape stepped a young man from rural England who would provide some of the most profound and enduring answers. Isaac Newton was born on Christmas Day in 1642, according to the Julian calendar then in use, in Woolsthorpe by Colsterworth, Lincolnshire. His early life was marked by the absence of his father, who died before he was born, and a period of separation from his mother when she remarried. This somewhat solitary upbringing may have fostered his intense focus and independent thinking, traits that would later define his scientific pursuits. He eventually went on to Trinity College, Cambridge, where he initially studied law but soon became captivated by mathematics and natural philosophy, what we now call physics. A pivotal moment in Newton's intellectual development occurred during the Great Plague of London in 1665 to 1666. With Cambridge University closed as a precaution, Newton retreated to his family home in Woolsthorpe. It was during this remarkably productive period that some of his most foundational ideas began to take shape. Now, let's get to the heart of the matter. What is Newton really known for? While the falling apple story might be apocryphal, it beautifully illustrates the core of his most famous contribution, the law of universal gravitation. Before Newton, the motion of celestial bodies and the falling of objects on Earth were seen as distinct phenomena. Newton, through a stroke of genius, realized that the same fundamental force governed both. He formulated the law of universal gravitation, stating that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law was revolutionary. It provided a unified explanation for a vast array of phenomena, from the orbits of planets around the sun to the tides of the oceans. It was a mathematical framework that could predict and explain the workings of the cosmos with unprecedented accuracy. Newton's Principia Mathematica, published in 1687, laid out this law and his three laws of motion, which form the bedrock of classical mechanics. These three laws of motion are equally fundamental. The first law, often called the law of inertia, states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. The second law states that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to its mass, F equals ma. The third law states that for every action, there is an equal and opposite reaction. These laws, seemingly simple, provide the foundation for understanding how forces affect the motion of objects, from a baseball being thrown to a rocket launching into space. But Newton's contributions weren't limited to mechanics and gravity. He also made groundbreaking advancements in the field of optics. Prior to Newton, the nature of light was a subject of much debate. Some believed it was a wave, while others thought it was composed of particles. Newton conducted a series of elegant experiments using prisms, demonstrating that white light is actually a composite of all the colors of the rainbow. He showed that when white light passes through a prism, it is refracted, bent, at different angles depending on the wavelength, and thus color, of the light, separating it into its constituent colors. He further demonstrated that these separated colors could be recombined to form white light again. This discovery not only revolutionized our understanding of light but also led to the development of the reflecting telescope. Traditional refracting telescopes, which use lenses to focus light, suffered from chromatic aberration, the blurring of images due to the different colors of light being focused at slightly different points. Newton realized that mirrors, unlike lenses, do not disperse light into different colors. By using a concave mirror to gather and focus light, he designed a more powerful and clearer telescope, opening up new possibilities for astronomical observation. The principles behind his reflecting telescope are still used in many large telescopes today. Beyond these monumental achievements, Newton was also a highly influential mathematician. He is credited, independently of Gottfried Wilhelm Leibniz, with the development of calculus. Calculus, a powerful mathematical tool dealing with continuous change, provided the necessary framework for understanding and describing motion, rates of change, and areas under curves. It was essential for his work on gravity and mechanics, allowing him to express his laws in precise mathematical terms and make accurate predictions. The development of calculus was a pivotal moment in the history of mathematics, providing scientists and engineers with an indispensable tool for analyzing and solving complex problems. Furthermore, Newton made significant contributions to other areas of mathematics, including the binomial theorem, infinite series, and methods for finding roots of equations. His mathematical prowess was integral to his success in physics and astronomy. It's important to acknowledge that Newton's intellectual pursuits extended beyond what we now consider pure science. He was deeply interested in alchemy and theology, subjects that were intertwined with natural philosophy in his time. While his alchemical and theological writings are less well known today, they were a significant part of his intellectual landscape and influenced his worldview. Understanding this broader context provides a more complete picture of this complex and fascinating figure. With that said, thanks for watching, and until next time.